All right, we're going to do volume again. This time we're going to do pyramids and cones. Last lesson we did prisms and cylinders. So we're going to do volume of prism or a pyramid and a cone. So let's take a look at the first thing we're going to do, which is a pyramid. This is straight from the book. I just took a picture of it, actually, cropped it and put it in here. So let's take a look at our formula for the volume of a pyramid. If you look, I've got like an oblique pyramid right here and a regular right pyramid where this hits right down in the middle of the base. This doesn't hit in the middle of the base, but the volume is still the same no matter if it's oblique or regular. All right, the height is obviously the dotted line right here, and it's perpendicular to the base. And if you look here, even though this thing is slanted, it's kind of tilted over a little bit, the height is still from the apex, I think is what they called it. Okay, this vertex up at the top, and if they took it perpendicular to the base, it would be right here. That's still the height. So that would still be the same height. So let's learn a formula for this, and it's really not that hard. Actually, let's do this. Before we do a formula, this is in the book as well. I should have put this in here. This kind of gives you a visualization of what this formula is, and I kind of like to do this so you can kind of remember what the formula is and see like where this number comes from. I got that little black line in there. Let's move that down a little bit. Okay. If you take a look, what we've done is we've put a pyramid inside of a cylinder that has the exact same base. All right, if you notice, it sits perfectly inside that cylinder, but this is a pyramid and it comes to a point. Now the height of the pyramid is exactly the same thing as the height of the cylinder. So is the pyramid going to be more than the cylinder? Is it going to be exactly the same as the cylinder, or is it going to be less than the cylinder? Well, if you take a look at it, it doesn't take up near all the space that cylinder actually has to offer. So when I take these sides and I point them in and they all come to a point right here, you have a lot of empty space all around here. And in fact, this pyramid takes up exactly one third of this whole entire cylinder. So if you can remember that, and that's going to help you with the cones as well. So the pyramid takes up 1/3 of the cylinder. Well, do you remember what the formula for the cylinder was? It was the area of the base times the height. There I go slanting again, but that's okay. But that's not the, this is the, I want to do a pyramid. Why am I writing? It's because I'm facing crooked. All right, there we go. Now I'm facing right. All right, so this is a pyramid right here. So the volume of a pyramid is 1/3 of the volume of the cylinder. This would be the volume of the cylinder, so all we got to do is put a 1/3 in front of it. Or some people like to write it like this: the volume is equal to the area of the base. Remember, that capital B means the area of the base, just divided by 3. However you want to see it or write it is perfectly fine. It's both exactly the same thing. So that's the volume of a pyramid. That's not too hard at all. It's kind of like the volume of a cylinder, except it takes up 1/3. So you could actually put 3, if you could like break it up and squish it in here, you could take 3 of these pyramids and fit it into one of the cylinders, providing that the pyramid and the cylinder have the same base, they both have the same height. You could put 3 of them in one cylinder. So it's quite a bit smaller. It's 1/3 of the original cylinder. All right, hopefully that makes it a little bit easier for you to remember. Let's do an example. Put some numbers in here, and we always like to do examples and see if we can figure this out. All right, this problem right here says find the volume of this pyramid, and they give you, I'll put volume right here. Okay, so you want to find the volume of this pyramid, and let's see what our formula is. We just did it about a handful of seconds ago. It's 1/3 the area of the base times the height. Sometimes I like to actually write in the word area of the base so you can kind of remember, but if you remember that the capital B stands for the area of the base, this is a nice, easy way to write it. So what are we going to do? Well, first of all, we got to find the area of the base. Well, what kind of base is it? See, this formula works no matter what shape the base actually is, as long as they give you enough information to find the area. Sometimes, if you remember in the last lesson, sometimes they tell you what the area of the base is. You don't even have to figure it out. So it'd be nice if they did that, but they don't do it on this one. So what are we going to do? Well, let's put the 1/3 in here. How do we find the base? This is a 4-sided figure. How do we find the base of this? Well, we take the, and it's a, it looks regular to me. So, and do they tell you it's regular? Nope, they just say it's a pyramid. So what are we going to do? We're going to take the base times the height, or length times width, however you want to see it, and it's 9.5 times 8. All right, so that would be this area right here. Remember, it's the area of the base times the height. So we have to now multiply it by this thing right here, which is the height. So all we do is stick a 9 in there. We chuck that into our calculator, and I'm looking at the answer. We should get 228, 228. Now, if this thing is in centimeters, which it says right here, our answer is going to be centimeters cubed, since volume is cubed. One thing I didn't say on the last lesson, I should have. I thought about it after I finished teaching the lesson. When it says cubed, remember on area, how many squares can you fit in that particular flat surface? On this one, how many cubes, how many 1 by 1 by 1 centimeter cubes could you fit and fill up every little nook and cranny of this pyramid? That's what you're doing. You're taking 228 square centimeters and you could fit it inside of this pyramid. Now, it wouldn't fit nice and pretty because it, you've got these angles and stuff, but if you kind of smushed it together, I guess, you could get the volume of this thing. So that's how many cubes can fit inside of this pyramid, 228 of them with those dimensions. It's not always going to be a nice rectangular square. This is a rectangle, not a square. But if it's not always going to be a nice rectangle. Sometimes it's a triangle, so you got to figure out what the area of a triangle is. Sometimes it's a different polygon, like a pentagon or a hexagon or an octagon or something like that. You're going to have to figure out sometimes what the area of that octagon is or what that pentagon is. Again, sometimes they'll actually tell it to you, which makes it really nice. But you got to be able to figure it out either way. All right, let's go to another one. Now we're going to talk about a cone. I stuck that cone inside of a cylinder right here. And so this is exactly the same thing as what the pyramid was. Remember, we put the pyramid inside of the prism? I'm thinking, did I say cylinder before? I can't remember. It seems like I might have. Anyway, this is a cylinder. Okay, so now we have a cone inside of a cylinder, and this takes up exactly 1/3 of it. Again, I could put 3 of these cones inside of this cylinder. So the formula is exactly the same. Wow, this volume thing is pretty nice because we're getting the same formulas for 2 different shapes. So it's 1/3 the area of the base times the height. But this time, since it's a cone, we always know what the base is going to be. It's not going to be different shapes. It's always going to be a circle. So we could, if we wanted to, write 1/3 pi r squared, because the area of this base right here, right there, is pi r squared, because it's a circle. A cone always has a base of a circle, and then times h. I guess you could memorize this if you wanted to, and I would not want to memorize this. This is what I want to memorize because I've memorized it for a pyramid as well as a cone. So let's write the cone right here. This is the volume of a cone. 1/3 the base times the height. Wow, couldn't be any easier. We have 2 different things with the same exact formula. That is nice. So let's do an example. I think that's all we need to say about that. Let's do it. Well, we're going to do 2 examples and we'll be finished. All right, here's your example. This is right from the book as well. It's on page, where am I? Page 858, if you want to look. Page 858. All right, pretty straightforward. We want to find the volume of this thing. Well, remember, the volume is the area, 1/3, the area of the base times the height. So we're going to go 1/3 the area of the base. We'll take a look. This is a circle. The base is a circle. And how do we find the area of a circle? It's pi r squared. I guess I didn't really need this parentheses right here and right there. I could have just done that, couldn't I? Yep. So there's the area of the base right there. There's the 1/3. Now we got to stick the height in here. They tell you the height. You didn't have to really figure out much at all. Just put the height in there. And now all you got to do is plug it all into your calculator, and you should get 62.2. 62.2. It's in meters, so it's meters cubed, because again, we're finding the volume. That's all there is to it. Really straightforward. There's not much to do with that. Now this one, do you see the point of this cone? It's not directly above the center. It's kind of slanted. We call that an oblique cone, oblique. But it's still the same exact thing. Notice, you take the height, it's not along the slant, it's not along the edges right here. It's from the top, perpendicular to the base. That's why they put that little perpendicular. So that's the height. It's got to be perpendicular, and that's the radius. It's from the center to the outside of the circle, and then you're good to go. All right, let's do one more. It's a little bit more tricky than this. They don't come right out and give you everything you need to know. So we'll try that one and see how that goes. Okay, they ask you for the volume again. All right, all these problems are asking for the volume, and what is the volume? It's 1/3 the area of the base times the height. So what do we have so far? We have the height. That's the height right there, 11. We know 1/3, obviously. The area of the base. How do we find the area of the base? Well, it's pi r squared. Problem is the r. I don't know the r, but they give us something else. They give us this 58 degrees. So I should be able to use that 58 degrees to use this r. Now remember, this is the height of this cone. This is the radius. It's perpendicular, okay, because the height will always be perpendicular to the base. Of course, the radius runs right along the base right here. So I could actually use a little trig function, couldn't I? Yeah, I got an angle. It's 58 degrees. What is this? This would be opposite, okay, of the 58 degrees, and this one would be adjacent to the 58 degrees. So what trig function uses opposite and adjacent? That would be the tangent. So we're going to take the tangent of 58 degrees. Aren't you glad you remembered all this stuff? I hope you remembered it. We went through it quite a bit in that chapter. So anyway, here we go. Chapter. Tangent of 58 equals opposite over adjacent. So the opposite is 11, and the adjacent, we don't know. We'll just call it r for radius. And let's move that up a little bit. We solve for r. Let's take the r, multiply both sides by r. That puts it up here. Divide by the tangent of 58. So I've got 11 divided by the tangent of 58 degrees. Now we're just going to chuck that into our calculator. I'm looking in the book to see what they get. They get about 6.9. Remember, it's approximately 6.9. That's our radius. That's what we wanted right here. Remember, we wanted to do this. 1/2 the area of the base, which is pi r squared times the height. So now we're ready to plug stuff in, and then we're good to go. That was the only extra thing that you had to do, was solve for the radius. So there's 1/3 pi, the radius, which is 6.9. We'll square it times the height. Now they were nice. They gave us the height as 11, and there we go. So that's everything we had to do. And then you just plug it into a calculator, and you get 548.4. This is in inches right here, so this is going to be inches cubed. So the volume is 548.4 inches cubed. And really, it doesn't really get much more difficult than that, I don't think, except sometimes the bases won't be so nice and pretty. Now on a cone, it'll always be a circle, so that shouldn't be too hard. But on the other one, the pyramid, sometimes you'll get a base that might be a pentagon, hexagon, octagon, something like that, that might take you a little extra time to figure out what the base is. But for the most part, it's pretty straightforward. Well, I hope you enjoyed this lesson. This was kind of easy, I think, anyway, at least as far as memorizing formulas. Just remember this thing right here. I really like this part right here. All right, where the cone fits perfectly inside this cylinder, but it takes up 1/3. 1/3. It's got 2 times as much empty space. Only 1/3 of it is taken up by the cone. Same thing with the pyramid. Okay, the pyramid takes up 1/3 of this prism. All right, takes up 1/3 of the prism. So that's an easy way to remember that the volume is 1/3 of the area of the base times the height. It's 1/3 of this cylinder, or in the other case, it's 1/3 right here. It's 1/3. I keep saying cylinder. I knew I said that earlier. I think I did. This is 1/3 of the prism. Did I say prism? I don't know. I'm not going to go back and check. I'm sure you're not either. This is 1/3 of the cylinder. All right, enough of that. You can go back and look. I'm just wasting time. Enjoy the rest of your day, and we'll see you in the next lesson.